right, we're going to look at our electrostatic force example here. So whenever we do electrostatic forces, we need to remember that our force equation, Coulomb's law, is this K times the two charges, absolute valued, so we're not worried about the sign on the charges, multiplied together divided by the distance between them squared. That K value, you should have that 8.99 times 10 to the 9th stored on your calculator. To get the direction of the force, I need to know, are they opposite charges, so like a plus and a minus, and then they're attracted, or are they like charges, they're both plus or both minus and they're repelled? That's how I get the direction. So when I ask you to find force, or I give you a force, I'm telling you two pieces of information that we can get using an equation and using the relative charge of those. All right, so let's go ahead and read this question. A negative charge of negative 0.55 microcoulombs, so that's what that little mu symbol stands for, is micro. So negative 0.55 microcoulombs exerts an upward force of 0.2 newtons on an unknown charge, 0.3 meters directly below it. What is the unknown charge, magnitude, and sign? And part B, what are the magnitude and direction of the force that the unknown charge exerts on the negative 0.55 microcoulomb charge? All right. So just looking at this situation, so I have a negative charge up here that is pulling this charge toward it. It's attracting it. So just from the direction of this force, I can tell, are they opposite or are they like? And so since it's attraction, they're opposites. This one's negatives. That one's negative. That means this one is going to be positive. All right. Now to find the magnitude of that charge, the Q2, I'm going to have to actually solve this force equation for one of those Q's. Now notice the absolute value on there. Again, we're just going to assume these are always going to be positive and just not deal with those absolute values, and we'll get the signs from our direction of our force. So let's go ahead and set our numbers in here. So I have a 0.2 Newton force is caused by K times the two charges. So I have this 0.55 micro. Now micro is 10 to the negative 6th. So this is 0.55 times 10 to the negative 6th. And now notice I don't have a negative sign in there. That's because it is an absolute value. I'm getting rid of those negative signs. Times my unknown charge, Q we'll call it, divided by 0.3 squared. So now I just need to multiply my 0.3 squared over, divide my 0.5 times 10 to the negative 6th. Remember when you're doing these powers, let's times 10 to the negative 6 stuff, make sure you're using that EE key to group it together, or you got to use parentheses pretty heavily. All right, well when we go ahead and solve this, we're going to get a Q value of 3.64 times 10 to the negative 6th coulombs. We'll go ahead and convert that. So I see that 10 to the negative 6. I know 10 to the negative 6 is the same as micro. So Q is going to be 3.64 microcoulombs. And I can get the direction from here. So I identified that they were attracted. So I know this is a positive charge. So the magnitude of the charge or the magnitude of the force or any of those things I get from the force equation. The direction of the force or the sign on the charge, I get that from looking, are they attracted or repelled? All right. Part B wants to know, well, if the negative charge pulls the positive charge up with 0.2, what does the positive charge pull the negative charge down with? And we all remember Newton's third law says opposite and equal forces. So this is a 0.2 Newton charge. Again, does it matter if I switch these two charges in my equation? No, I'm going to get the same value. Okay, there's your example.